We are going to solve this problem here where we have let's see, suppose we have a sine, and the sine weighs, let's say, 40 kilograms, and it's being suspended by two cables. One of them makes a 30-degree angle. Let me draw that a little steeper. So let's say one of them makes a 30-degree angle and the other makes a 20-degree angle. And there's gravity pulling directly down on this. So I'll call that a force due to gravity. And we're going to say that this cable has tension 1. I'm going to call this tension 1, and this one here has tension 2. So a couple things here. What our goal is, to find tension 1 and tension 2 in this setup. A couple other things. We're going to use G equals 9.8 meters per second squared. This is acceleration due to gravity on Earth. So we're going to just keep that in mind, and we're going to use Newton's second law, which is F equals ma for part of this as well. So the first thing I'm going to do to solve this is we're going to break all this stuff down. We're going to say tension 1 has a vector pulling upwards, which we'll call T1y. And then tension 1 also has a vector pulling to the left. That's the x direction, so we'll call that one T1x. And tension 2 has a similar pair of vectors. There's one pulling straight upwards, which we'll call that one T2y. And then there's one pulling off to the right-hand side, which we'll call that one pulling off to the right-hand side. We'll call that T2x. Okay, so we're going to want to kind of view this, since this thing is, the sine is not moving, this 40 kilogram sine is not moving, it's stationary. We know the two forces that pull up must be equal to the force that pulls down, because the sine's not moving, so they have to cancel each other out. And this force pulling to the left has to equal the force pulling to the right. So we're going to use that idea in order to get this thing solved. So first of all, I need to break this T1 down. I need to break it down into its T1x and T1y. I need to break it down into these two vectors. So I'm going to label this, for this triangle here, this would be h, the hypotenuse. This T1x is next to the angle, so that's adjacent. And this 20 degrees here, this T1y is the opposite side. So I'm going to use CAH to figure out T1x, because I know the hypotenuse is T1, and that's one of the two things I'm asked to find over here. So, sorry, let's box our goal in to keep it kind of clear. That's the main thing we're going for is over here. Okay, so cosine of my 20 degrees, that will equal adjacent, which is T1x, over hypotenuse, which is T1, just T1. So I can multiply T1 across and get T1 cosine of 20 is my T1x. So I'm going to box that in because now I know for T1x, I know a way of representing this blue line. So I'm going to repeat the process for O and H, which means I'm going to use SOH, to get sine of my angle equals opposite, which is T1y, over T1. And then the T1 can multiply across, so we'll get T1 sine of 20 is T1y. So that was from SOHCAHTOA again. And so now I also know what T1Y is. So I used SOHCAHTOA and I was able to break, this one triangle here down to its X and its Y component. So I'm going to repeat the process over on this triangle to generate stuff. So T2 is our hypotenuse H. Since the angle 30 degrees is here, T2y is across, so that's opposite. And T2x is next to the 30-degree angle, so that's adjacent. So when we want to find the T2x, we're going to use CAH, because we know the adjacent and the hypotenuse. So we'll say, all right, CAH. This says cosine of 30 equals adjacent, which is T2x, over hypotenuse, which my hypotenuse is just T2. So the T2 can multiply across, and we'll get T2 cosine of 30 is my T2x. So we'll box that in because that's the one that we want. So now I know what T2x is, and I just need to figure out the T2y so I know what's going on there as well. So we'll use O and H, so that means we're going to use SO. So sine of my angle, sine of the 30, equals opposite, which is T2y, over hypotenuse, which is T2. T2 multiplies across, so we'll get T2 sine of 30 equals T2y. And I'll box that in. Okay, so we know we have a way of representing the two forces pulling up. We have a way of representing the force pulling to the left. And we have the way of representing the force pulling to the right. So real quick, just kind of labeling stuff. This one right here is pulling to the left. This one down here is pulling up. This one here, the T2x, pulling to the right. And this one down here is pulling upwards. We need to figure out what's going on with force due to gravity. So we're going to use this equals mass times acceleration. The mass is 40 kilograms. The acceleration is 9.8. So we just need to figure out real quickly what's 40 times 9.8. And let me use Desmos to get that. And we'll say, all right, 40 times 9.8. 40 times 9.8. And we get 392. So that tells me that this right here, the force due to gravity, is 392. That would be newtons. And this one right here is pulling down. So that's pulling downwards. So basically we have two forces pulling up and one force pulling down. We have one force to the left and one force to the right. So we're going to kind of balance stuff out by just kind of the directions that things are pulling. So let's say up and down, we'll balance that out here. So T1y plus T2y, that's those are the two forces pulling up. They would equal the force pulling down, which is the 392 newtons. And then we have another one where we want to balance the force pulling left and right. Again, since the sign's not moving, all of these things need to perfectly be balanced. So we're pulling to the left by T1x, and we're going to pull to the right by T2x. So in the next step, I'm going to replace T1y with what it actually equals here. I'm going to replace T2y with what it equals there. I'm going to replace T1x here with what it equals up here, and T2x with what it equals there. So T1y is really T1 sine of 20 plus T2y. T2y is really T2 sine of 30. So that's really T2 sine of 30 and that's going to equal 392. T1x is T1 cosine of 20, and that's going to equal T2x, which is T2 cosine of 30. So now to move on with stuff, what we're going to do is we're going to solve this one here for T2. So I'm going to divide the cosine of 30 across. So cosine of 30 cancels over here. And I'm going to rewrite this. I'm going to write the T1 at the end. So we get cosine of 20 over cosine of 30 times a T1 is a T2. So we know what T2 is in terms of T1. So now what we're going to do with that information is we're going to take this part right here. This is what T2 actually equals. T2 is equal to this. So we're going to replace the T2 over here. We're going to replace that T2 with this statement here. So what that's going to look like, we'll kind of say, okay, we did that. So this whole bit here, we're going to kind of say what that looks like down here now. T1 sine of 20 still stays the same. Plus, instead of T2, it's cosine of 20 over cosine of 30 times T1. And that's being multiplied by sine of 30, so it has times a sine of 30. And that whole thing equals the 392. Okay. Now, both of these terms on the left have at least one T1 in them. So I'm going to factor out that T1, and that's going to let me rewrite this as T1 times, if I remove the T1, the sine of 20 is left behind there. And if I remove the T1 from this term, the cosine of 20 and the cosine of 30 are left, and the sine of 30 is left. So we get cosine of 20 over cosine of 30 times sine of 30. And then that all equals 392. So we're going to divide all this parentheses stuff across, and we get T1 is equal to 392. All that divided by sine of 20 plus cosine of 20 over cosine of 30 times sine of 30. So I'm going to put that into Desmos, and we'll see what we end up getting. And then, okay, let's see here. We got 392 divided by, oh, I need to switch Desmos over to degree mode. If I don't do that, everything's going to be wrong when I use my trig functions, because we're dealing with degree angles here. So it's sine of, whoops, I need that in the bottom part here. It's going to be sine of 20 plus cosine of 20 divided by cosine of 30. And that little bit there times the sine of 30. That's 433 or 443.16 is the tension there. So 443.16 is the tension in the tension 1 rope. So this is T1. And then to find the tension in T2, we know T2 equals cosine of 20 divided by cosine of 30. So all we have to do is plug in the value that we now know for tension 1. So I'll do 443.16 times, or cosine of 20 over cosine of 30. So So we'll say cosine of 20 divided by cosine of 30. All that times the 443.16. And that gives me 480.86. So tension 2, that will be tension 2. And so at this point, we've solved the stuff it wants us to. We found tension 1 and tension 2. So we are done, and that's basically what we got.